Hey everyone, this is Mayur. Welcome back to MLWorks. In this video, we'll be discussing about Ray Serve for Kubernetes. So, in the previous two videos, what we have done is we created an application like translation and summarization and turned that into a Ray Serve deployment. And then we combined those two models together to form one HTTP endpoint. And we talked about basics on the parameters like replica, CPU, and GPU resources. That was our first video with respect to Ray Serve. In the second video, what we done is we used Serve CLI, which is a way to deploy your Ray service as a Ray app or Ray service app, okay, which will be again creating a service inference endpoint for you to hit. Now, what we'll do is in production environment, what happens, right? You will be putting your Ray service on a Kubernetes cluster running as a pod, okay. And to scale your Ray service or inference service, you will scale the pod number of pods, increase the number of pods, and then you can take in multiple or concurrent requests, okay, in a scaled environment. Now to do that, okay, there are a bunch of things that needs to be taken care. First of all, you have to create a Ray service YAML, okay, which will be containing your Docker environment and your model file. And your model file will be running on the Docker environment. Now the Docker environment is nothing but your Ray environment because you want to turn that into a Ray service or inference service. Okay, so that's the one part. Okay, now to communicate between your Kubernetes cluster and your Docker environment, you need something like Ray service with respect to again kuberay. Kuberay operator helps you to create Ray service, and Ray service communicates with your Ray application inside your Docker environment. So that's that. Now in this video, what we'll do is first we'll be talking about our application, okay, which is our model, okay, and then we'll be turning that model into a zip file, and which will be referenced. That zip file will be referenced inside a Ray service YAML, and which will be running inside a Docker container, which is nothing but a Ray image again. So first thing, right, let me go to the application. So here we have an application which takes in two models, which runs two models as a Ray service or Ray deployment. First thing is, I already talked about this specific application in the previous video. I'll be quick on this video. What I'll describe is there are two deployments, Ray service deployment. One is the translator and other is the summarizer. The translator will give you the output in translation. Whatever the input text you pass, it will give you corresponding output text as a translation. And it was turned into a Ray service deployment by adding this decorator @serve.deployment. Okay, this is a Python class, and once you add @serve.deployment, it will be turned into a Ray object. And here we have summarizer, which is again a Python class, and then here it takes in the input and it will summarize the text for whatever input you give. The only thing is, if you see here, it takes in translator, which is nothing but a deployment handle object. So you want to combine two models here, okay, translator plus summarizer. So that's why we want to take this as our input, okay, and we'll be using this translator object to translate whatever the text that is summarized. So if you see here, first we'll be doing summarization, and the output of that summary is passed to the translator. Now the first important thing to understand here is the call function, because as I said, we'll be having two models, translation, summarization, both will be combined together to form one Ray Serve deployment, which is one HTTP endpoint. So any request that comes to that particular HTTP endpoint, okay, it will be passed here, and then you will be turning that into a JSON, and you will be extracting the text and summarize the text and then pass that output into translator as an input, and then you'll get the translation. So this is the whole thing, and you combine that together using this bind function. Summarizer.bind with translator.bind, you'll be combining these two models together. So this is the Ray Serve deployment of two models. Now coming back to, now we talked about the application. Okay. Now we want to zip this application and store it somewhere in a remote URI, because it is what I've heard from the documentation is you cannot take it from the local object. Okay, you cannot use that particular zip file from local object. You have to store it from the remote URI. You have to store it in remote URI. So what I'll do is the same file which is ray trans sum, right? So it is stored in my one of the GitHub repository, which is ray_trans.zip. That particular file is present here in this zip file. Now this specific path, okay, let me go to this, click this, and I'll be taking the raw. What I have to do is I have to pick the URL from here. Okay, copy this link. Okay, what I have to do, I'll just show this. Here instead of blob, you have to turn that into raw, and you will be able to download this zip file wherever in the environment. Because here what we'll do is we'll be referencing this URL inside the Ray environment or Ray service YAML. Okay, let me go to that YAML first. So here we have Ray service YAML. So first thing is we have to have Kubernetes cluster and Kubernetes operator up and running inside our environment, inside our Kubernetes cluster. Now we have to use Ray service to deploy our Ray service inside a Kubernetes containerized environment. So for that, what we have to do is first we create a Ray service, and here the spec part, okay, if you see here, we are referencing the specific URL, okay, which is again this one, and ray_transum.zip, and here we'll be downloading this particular zip file, and it will be unzipped inside the Docker environment, which I am creating here. Okay, these are the image name I'm giving, right? Okay, it will be passed here, that particular zip file, and we want to run a specific Ray service app, which is nothing but ray_transum:app. Okay, if I go back to that specific file, okay, which is ray transum. Okay, if you see here, the file name is this is not the file name actually. Okay, I have changed the file name in the GitHub repository. Okay, so it is ray_transum and it is the app. Okay, so if you see here, it is the ray_transum:app. We have to reference exactly that Ray service deployment here. Okay, and this is the runtime environment for this particular application. Okay, and here if you see, I am setting the config as setup timeout seconds is equal to 1200. So by default it will be 600, that is 10 minutes. What happens, right? Sometimes people, what they do is if there are certain packages which are required by your model, they'll be passing it here. Okay, like for example, torch is equal to some 2.1. Okay, so while you are installing this, okay, it may take some time. Okay, if it is less than if it is taking more than 600 seconds, okay, then the runtime will stop. So we can modify this configuration, set up timeout seconds to greater number, okay, such that you are able to install all the packages that are required for your model. Okay, I'll just take this out. So now this is with respect to the code, right? Application code. Now comes the part where you create a Ray cluster where this Ray service will run. Okay, so here you have Ray cluster and the Ray version that I am using, right? The base image which I used is also 2.3.8. If I go to the Docker file, this is the Docker file I created and Docker image that I created, and this was the Docker file that I used. So here I use the base image 2.38.0-CPU, and these are some packages that I wanted to install inside the for running my application, which is translation and summarization. And these are some packages that are required: Hugging Face, Transformers, Torch. Okay, these are some packages that I require. So I create a new image out of this base image. Okay, so that is, we can see it here, Mayur, Torch, HF, which is Hugging Face, CPU, Ray 2.38, and 2.50 means Torch 2.50. Okay, the thing is, even if you don't, there are some compatibility issues when it comes to Torch. Okay, if you're using 1.9.0, okay, then it is not supported. Certain parameters are not supported with respect to this specific array. So that you have to make sure that the whole thing is compatible. The array is compatible with the Torch also. Okay. Now, so here what we are doing is, okay, we are creating a head group, and the head group will be, it's nothing but a pod, and that pod is running this specific image, and this is the resources for it. Okay, I need 2 CPU, 4 GB RAM. This is my limit, and this is my request also. because this is a single node, I don't have like what huge memory or CPU available, so I'm using that. And this Ray head, right, it will also be exposing these ports and for accessing different kind of services like Ray service at 8000 and client and dashboard and GCS server all will be running inside. Now comes the part where the worker group is set up. Okay, here we have replicas. I am keeping it as one replica because I don't have resources to create multiple replicas. So for now, I'll be creating one replica, max and min, or also one. And in the template part, again, I'm mentioning the image name. Okay, where I want to run my ML model. Okay, so this is that, and here I'm again keeping the resources as CPU as 4, memory as 6 GB, request is 4, and memory also 4. So this is the environment for me to run my application, which is two models inside a worker node. This is the worker group. Worker node or worker group, both are same. Okay, and it will be running, and the Ray service will be running on 8000 port. Okay, make sure you note that. And also one thing to understand, right? So the Ray that you are using here, okay, for example, this is a pip package that you are using. Okay, it is a specific version. This specific version and this specific version should match. Okay, make sure you note, understand that, because you cannot have a cluster or an environment running on specific Ray version and your code is expecting some different Ray version. Though both should be matching. Okay, so that's one point. And so we have this image. So I talked about the Docker file. Okay, so if I see the Docker file, we created an image and we used that image inside our Ray service YAML, and we pointed out which specific machine learning or ML code that we want to run from the zip file. So we mentioned all those. Now what I'll do is I'll show you how to run that. Okay, so let me save this. I guess I have already Minikube running. Okay, get pods. So I have a couple of things already running. These are like Prometheus that is running. I want to delete this. Okay, let me clean this, not required. So what I'll do first is I'll go to my environment, which is virtual environment for Ray service. Bin activate. Now I have my Minikube up and running. So what I'll do is first I'll be running this Ray service. kubectl apply -f Ray service and Ray service, not this one, Ray service trans sum YAML. So this is getting created now. Text summarizer is getting created. Now first we have to check if my get Ray service is up and running or not. So it is restarting. Let us watch this, how it is running. Okay, it will keep, the status will keep changing. Okay, we have to understand that. And while that is changing, let's see if the pods are getting created or not. Get pods. So here 23 seconds ago, these two pods started getting created. So one is running, one is, okay, it is in running, status is running, but it is not ready. It is 0. And the other one is in the initiate state, which is nothing but this is a head node, and this is a worker node. Okay, so let me go here. So it is still in the restarting state. Let's see. Wait for this one to run. Get pod. So yeah, so if you see here now, okay, this is, let me clear this again. Okay, so if you see here the head node, okay, now it is ready also. Okay, let me do something like describe this pod, kubectl this pod, and let's see, right, what comes up. Let's understand certain logs. So successfully assigned this one to Minikube. So it has assigned this specific pod to the Minikube. The container image was already present. Okay, they created the container Ray head, started the container Ray head, and readiness probe failed. Okay, nice. Let's wait. So wait for service deployment, serve deployment. Okay, let me go back. Okay, let us describe. Let us describe the Ray service, right, which is text summarizer. So the service is not ready, controller will perform a round of actions. Okay, so what I'll want to show here is, so we are inside the Ray service. Okay, we are keep on seeing the status. Okay, currently it is deploying status, and the summarizer is updating and translator is also updating. Let me again run this. Okay, now the status has changed. Now the summarizer, the health last update time was this, and the deployment summarizer in application text summarizer has one replica and that have taken more than 30 seconds to initialize. Now this is for summarizer. Now it is also updating status. It is not in healthy status, it is in updating status. Now you have translator, again the same set of message we are getting, and the status is updating. Now the status for the whole Ray services, it is in deployment status. Okay, let me run it again. So it is still in the deploying status. It will take some time to run. Okay, we want to run 2 pods. Okay, and in those 2 pods we want to run the 2 applications, which are the 2 models. So that's why it is taking some time, and also I have less amount of resources to run, so it will take some time. So here if you see, okay, I'm checking the Ray service status. Okay, first it was in restarting state, it is now in wait for serve deployment ready. Now it will continue to update every 2 seconds. So let me run this again, clear this, describe Ray service. Okay, here we are again seeing it is updating, it is also updating, and it is deploying. Okay, now what I'll do, right, kubectl, I'll also go to the service, right. Here if you see, there will be a service getting created, text summarizer, Ray cluster. Okay, this is my cluster, and I'll also have an head service and a worker service kind of stuff that will be coming up in some minutes after the pod is running. Okay, so this will take some time. Let's wait for a few minutes. Describe the Ray service. It is still deploying and updating. The service is not ready. The controller will perform round of actions. Let me go to the pod. Get pods. So this is running. Let's see what is the describe when you do this specific pod, right? Smaller work group. kubectl describe pod. So here readiness probe failed. This is getting failed because our Ray service is not up and running. That's the main reason for it. Okay. Once it is up and running, then we'll have everything up and running here as well. The readiness probe failed will be disabled and it will be success. Let's wait few minutes. So while this is running, okay, what I wanted to talk about is, now see what is happening in the backend, right? Let me go here in this configuration file. So in the backend, it is creating a cluster, which we already saw, and then it is creating a pod, which is head group pod, and then it is creating a worker group pod. Now this will also create something called as, this is a pod, it's getting created, it's also create something called as service. Now what will happen is exposing the service outside such that we can access it later. If you want to do inference, right, we have to expose the service through port forwarding. So that needs to be done. Okay, that's what we'll do when we want to hit that particular endpoint for the specific application. In this case, these 2 models is our application. So let's see again. So yep, we are there now. Okay, so if I see here, okay, the status, now we have text summarizer, our application, under which we have summarizer model, which is healthy, which is our Ray Serve deployment, and translator, which is our Ray Serve deployment, which is also healthy. Now our Ray service is running, it is healthy and running. Now everything is done. Okay, it's up and running. Now let's check if our pods are running, both the pods. Now if you see the smaller worker group, right, that pod is also running, and the head pod was already running as we saw earlier. Now let me go to the service. As I said, we want to expose the service outside through port forwarding such that we can hit the model. Okay. So let me go to the service, get the service details first. So this is the head one. Okay, this is the Ray cluster. So the thing is, our application will be running on worker node, not on the head node, because head node is like a control plane. Okay, it manages or it assigns tasks to the worker node. It won't do any task, it will just assign the task. So our application will be running on worker node. Now correspondingly, you will have service for that particular worker node. You will have some specific service, which is nothing but this one. Okay, now it is running on 8000, our Ray service. Now what I'll do is, I'll be kubectl port forward, and my service name is text summarizer and serve.svc. Now it is port 8000. I want to host it on the local machine also. I want to use only 8000. So what I'll do is, I'll give just 8000 and it is port forwarded now. Now if I go back here into the YAML file, I want to just show one more thing. If you see here, we have this specific application name and everything is here. Now if I see anywhere, if I mentioned anything else, any route, okay, we did not mention any route, so it should be /8 localhost 8000 / should work. We did not give any route here. So let me, so is it like I have given it in the application file or something like transum? Here did I mention it? No, it is not mentioned anywhere. So fine, what I'll do now is, I'll just use this client. Let me go here in this specific, okay, so if you see, right, the status is also updating here from wait for serve deployment ready to running. Both are running now. Now I'll go and go to another terminal, okay, and change it to Ray Serve, and here I guess I have my client. I guess client is this one, summarize. That's the thing, right? I have tested this one. Okay, let me just run this. Okay, this client, this will hit that service. So Python 3 client, this should not work. Okay, the reason being this path is not present. Okay, I think I have mentioned it in the previous example, I guess somewhere, the route. Okay, this is the summarize translate. Okay. So here we have So if you see here, I am running my app, okay, and I'm not passing any. Okay, let me go to this kubectl get Ray service -o YAML. So here I have this deployments. Okay, I'm not seeing any routes anywhere mentioned. Summarizer, text summarizer. But anyway, what I wanted to show is, see, by the client from this particular file, right? What it is doing is, it is going and hitting that service. I'm using this specific path, summarize translate, and I'm passing my input. And it is, what it is doing is, it is first summarizing my whole line and then translating it, and that's what we saw here. If I just run it again, okay, you will see that output here. Okay, this is the summarized summarization, and for after that translation. So what we are able to do is, we are able to hit our Ray service for the application. Now what I wanted to talk about is, I want to talk about this specific YAML, okay, especially this specific YAML, because here if you notice, I just did not mention any replicas here. What I can do is, there are like many parameters that you can pass. For example, replicas can be passed here. I'm running it as 1. Okay, this is the head node, not on the head node, but on the worker node. where is the worker node? Yeah, this is the worker node right here. I just have given replica as 1 and min as 1 and max as 1. If I give 2 and this has 1, so I'll turn this as 2 and this gives as also 2, like 4 at max it can go. And yeah, let's keep it like this, right? By default I want to run 2 replicas, okay, and it should have minimum 1 replica and it can have maximum 4 replicas. So this is my configuration. Now I'm not sure if this will run because it requires this amount of CPU and memory. So what I'll do is I'll just delete my this one, Ray service, kubectl delete Ray service text summarizer. Okay, so this is deleted. Now I have given 2 replicas. Okay, now there will be 2 worker pods will be getting up and running. Okay, and I can concurrently hit the 2 concurrently run the this particular endpoint. Okay, such that it can handle more requests. But I'm not sure if this will work because based on the resources that I have, I'm not sure if it will work or not. So kubectl apply -f which is again Ray service and trans some YAML. Okay, so it is getting created. kubectl get Ray service. So it is restarting state. Let me run it again. And so again, yeah, it is again restarting here. I don't need to run this, stop it. And while this is running, this pod is also, because this is from the previous, I want to stop this. And the kubectl get pods. Let me watch this also. So it is currently in the this state, running state and pod initializing state. If you see here now, so if you see here, there are 2 small worker groups. Now it was in pod initializing state and after that it turned into running state. So this is great. Okay, I'm able to run 2 pods. Okay, that's great. The thing is, it is still not ready. Okay, it is still waiting for it to run because we want to have those resources available for the pod. So this is running. So this is what scaling refers, right? Like you can have multiple pods and you can hit any endpoint. You can hit the endpoint and it will be redirected to any of the pod based on its availability or the amount of traffic that it is currently taking in. Okay, so that's why you can scale your application using Ray services when you are hosting it on Kubernetes. So what we have seen right till now in this specific video, we talked about application, which is like 2 models, how it is turned into Ray Serve deployment and how we combine this together using the .bind, and then we zipped it and stored it in a specific remote URI. In this case, it is GitHub, and you can also store it in some other place like S3 path or any other remote location. You can store it there. So that is that. And then what we did is we talked about the Docker file, okay, where I used the base image of Ray and installed certain packages which are required by my application, and then I created a new image and which is stored in my Docker Hub repository, and it is getting referenced in my YAML file, which is here. And then we went to the YAML file where I talked about the serve config v2, where I am referencing my particular application, which is raytrans yap. Okay, here this is the file that is getting stored in this zip file, and I'm referencing that, and I'm just talked about some configurations that you can manage from your end. And I talked about Ray cluster, where you have head and worker node. Head will be like the control plane, which will be assigning the task to the worker node. Now these are the important ports that needs to be enabled or should be by default should be present in your YAML file, and the container port 8000 is where your service will run, Ray Serve will run. Now here in the worker node, we talked about how to scale the things using replicas, and then we talked about the containers and also the resources corresponding to it. Okay, and once you are able to up and run these things, you are able to hit that particular thing using client, which is sending the request, some summarizing text and then translating it. So we were able to do all these things. Now, if you see in the terminal right here, everything is up and running. Okay, this is up and running here. Ray cluster, the smaller group. Okay, what I'll do, right? Let me stop this. Let me just do Ray pod. Okay, so it is still not running actually. If you see the worker small group, right, it is not running. The Ray cluster head is running. If the Ray service is running or not. Yeah, Ray service is running. Ray service is running. The pod is not able to run. Let me see get pods. Okay, let me see what is the problem here. Describe pod. It may be because of the resource issue. Prop failed. Okay, reason is mentioned anywhere. Status. So shared memory 4 gigabytes burstable. So container readiness proof failed. Pod is scheduled. Containers ready. False. So there are a bunch of things present here. Is it somewhere mentioned that the memory or resources missing or something? So let me again hit. This is get pods. So let me check the logs of this specific pod also. This will be helpful. Okay, so the Ray runtime got started. Okay, and then the message will be printed if any of them terminate unexpectedly. So I think it should work. Maybe it's not working because of the resources. Because I have only around 16 GB, right? If you see at the YAML file, 16 GB here. I have already 4 GB assigned, 2 replicas 8 GB, and then I have again 12 GB. And there are many other pods that are already running, which is already consuming a lot of memory for me. So I'm not sure if this will work or not, and it's also not giving me any error as well right now. We have to keep checking. So anyway, what I'll do is, with respect to what we wanted to achieve, we were able to do that. Okay, so what we have done is we have created Ray service and we deployed our model inside the Ray service and then hosted it on Kubernetes cluster. We were able to hit through our client. So with that, okay, I'll conclude this video. I hope you understood how to use Ray service on Kubernetes such that you can able to scale your inference service to larger scale. So with that, thank you for watching. See you in the next video.